this video, we're going to look at equations of circles centered at the point AB, where A and B can be any numbers. So in the previous video, we looked at equations for circles centered at 0, 0 at the origin, because these are a little simpler, so it's a good way of introducing the idea of a circle equation. But now we're going to look at the general equation of a circle, which could be centered at any point. So I would recommend watching the previous video first if you are not familiar with circle equations at all. So the equation of a circle with radius r and center AB is x minus a squared plus y minus b squared equals r squared. So we're not going to go into the proof of why this is the case. It's not too hard to prove, it just involves a bit of geometry and drawing diagrams, but it's good to just remember this formula as it's very important. So if you want the equation of a circle which has a radius r and is centered at the point AB, it's x minus a all squared plus y minus b all squared equals r squared. So any 2 points x, y that satisfy this equation will lie on a circle centered at AB and with radius r. It's worth noting that in the previous video when we talked about circles centered at the origin, we said the equation for those were x squared plus y squared equals r squared. Well, that is actually encapsulated in this equation, because if we want a circle centered at the origin, a and b are both 0, and if you plug 0 in for a and b into this equation, you end up with x squared plus y squared equals r squared, which is what we had. But this is a more general equation for a circle centered at any point. So let's try and do a few examples. Example 1. Find the radius and center of the following circle with equation x minus 2 squared plus y minus 1 squared equals 4, and sketch it. So we have 2 points to this question. We first have to find the radius and center of the circle with this equation, and then we have to sketch the circle. Well, once we have the center and the radius, the sketch will be quite straightforward. So let's look at this equation and let's compare it to the standard equation at the top. We know that the number being subtracted from the x is the x coordinate of the center, and the number being subtracted from the y in brackets is the y coordinate of the center. So we can see that that's 2 and 1. So center, so we'll just highlight that here. We have x subtract 2 and y minus 1. So the center is 2, 1. So now what is the radius? Well, we look to the right hand side of the equal sign and we see we have 4. Now that should be the radius squared. If you look at the equation, it's r squared. So r squared is 4. So r is square root of 4, which is 2. So it's circle with radius 2 and centered at 2, 1. So let's note the point 2, 1 on our axes. Here it is, this red dot. And we want the circle to be centered here and have radius 2. So let's go 2 along from there in the x direction. Now if you were to drawing the circle freehand on paper, you would want a circle that goes through the end of this line with the red dot as its center. So it would look like this. Okay, let's try just one more, slightly more complicated example. So example 2, find the radius and center of the following circle with equation x squared plus y squared plus 4x plus y minus 1 equals 0, and sketch it. So this looks a little horrible maybe at first because the equation doesn't really look anything like the equation at the top. And the equation at the top is the standard equation for a circle. But as is often the case with a lot of equations, this equation can be rewritten. You wouldn't necessarily know just from looking at it that it was the equation of a circle, but since we're told in the question that it is, we can be quite confident we should be able to rewrite it so that it is of the correct form. And when it's in that form, it's quite easy to pull out the radius and the center, and therefore it's quite easy to sketch it. So we just need to get it into that form. So let's have a look at this. Well, this is our equation. We want an x bracket and a y bracket, so a bracket with an x in it being squared and a bracket with a y in it being squared. We don't have that, so let's try and force one in. So we'll start by gathering up our x terms together and gathering up our y terms. So you can see we have an x squared and a 4x. So let's write those down. X squared plus 4x, and then we have a y squared and a plus 4y. So we'll write those down, plus y squared plus 4y, and then we've got the minus 1 at the end, and the whole thing equals 0. So we haven't changed the equation, we've just reordered some of the terms. Well, now if we just look at this first part, so we have x squared plus 4x. We want to put that into a bracket where we just have a bracket squared with a single x in it. Now this is called completing the square. Hopefully you're familiar with this process. If you're not, there is a video in the algebra series of videos that covers this topic, so you should go watch that first to learn about completing the square. But that's what we need to do here. So hopefully you remember, if you have seen that video, if you know the process, that you half the number in front of the x term. So we half 4 plus 4 and we get plus 2, and that's what ends up in our bracket. So we end up with x plus 2 squared, and then if we were to multiply out this bracket, we'd end up with a x squared term, and then we'd end up with 2 times x and another 2 times x, so that's 4x, which is what we want. We want x squared plus 4x, but we'd also then end up with a plus 4 because we'd have 2 times 2. So we subtract 4 from the bracket to make sure it stays equal. So x plus 2 all squared minus 4 is equal to x squared plus 4x. Once again, if you know how to complete the square, hopefully this makes a lot of sense to you. Now it's the exact same story with the y, since it's the same numbers, so y squared plus 4y is what we have here, and that is just equal to y plus 2 all squared minus 4. So we half that number in front of the y and put that in the bracket, and then we think what that would give us when we squared it out, and we subtract that back off to keep it equal. Then we have to keep the minus 1, and the whole thing is still equal to 0. This looks a lot better now. The only issue is we have all these loose numbers, and if you look at the standard equation, these should be on the other side of the equal sign. We want all our numbers to be added up and placed on the right hand side, because that is where the radius squared sits. So we'll gather up our bracket terms, x plus 2 squared plus y plus 2 squared, and we'll stick all the numbers on the end. So it's minus 4, another minus 4, and a minus 1 equals 0. So once again, I haven't changed anything drastically, I've just reordered the terms. So now we'll just rewrite this as x plus 2 all squared plus y plus 2 all squared minus 9. So we've gathered up all these numbers at the end and combined them. So minus 4 minus another 4 is minus 8, minus 1 is minus 9. Finally, we put this onto the other side of the equal sign, and we get x plus 2 all squared plus y plus 2 all squared equals plus 9. And now we see this is indeed a circle equation. We have x plus some number in a bracket all squared, y plus some number in a bracket all squared, and it's equal to some positive number, which is important. If that was a negative number, it wouldn't make sense, since it's the radius squared, so it has to be positive. So we can sketch this. Now let's just be very careful and look at this bracket. We have x plus 2. Now in the equation, we say that if it's centered at AB, we need to have x minus a and y minus b. So we have to note that x plus 2 is the same as x minus minus 2. So that means that the center of this circle is actually at minus 2 minus 2, which we can plot here. So this red dot is the center. So when you have x plus 2, that means the x coordinate of the center will be minus 2. So if you like, you sort of swap the sign that's in the bracket when drawing the center. So we have the center here, and we know that the radius squared is 9. That means that the radius is 3. 3 squared is 9. So we can draw a line here, and therefore the circle looks like that.